Hello, welcome to this video. In the last video, we spoke about how if the variables is referenced to other variables, the reference count of that variable increases. Here, we had a variable of a with the value of 1, 2, 3. That is an array with the values of 1, 2, 3, and it was pointing to the memory address of 0x106. So this memory address had a memory reference of one variable. So the reference count became 1. And as soon as we assign the variable b with the variable a, now the variable b was pointing to the same memory address, that of a. So the memory address 0x106 now had two memory references with it, the variables a and b. So the reference count became 2. Now, when we assign the variable c with the variable c was referencing to the same memory address, that of a. So, the memory address 0x106 now has three memory references, that is the variable a, b, and c. So, the reference count goes to 3. As soon as the reference count goes to 0, JavaScript Memory Manager destroys that object, making space in the memory. In this video, we'll have a quick walkthrough using Python to calculate the number of references. To save time, I already have a Python file which is going to give us the output of the number of references. I am printing the reference count of the variable with the reference counting function, which is defined here. The reference counting function takes in a parameter called address. The ctypes module takes in the ID, that is the address of the variables, and it spits out the reference count of that variable for us. Here we are passing in the address and we are returning the reference count number. Now when we print, before printing, let's see. Here we have a variable with an array 1, 2, 3. In Python it's called as list. Here we have a variable with the values 1, 2, 3 inside of an array, and when we print the ID of a, we get the reference count to be 1. Let us see the reference count. I am running the file python reference count. We can see that the variable a has a reference count of 1 and the address of the variable a is pointing to so and so address. Now when we assign the variable b with the value of a, and when we print out, we can see that the reference count of a now increases to 2. As said, reference count of the variable a is 2. Now when we assign the value of a to the variable c, and when we print the reference count of the variable a, we can see that the reference count of the variable a is 3. Now let us remove the values c and b, that is, let us assign the values of none to the variable c and b, and when we print the reference count of a, now we can see that the reference count of the variable a is 1. Here we are assigning c the value of none and b the value of none. So c and b are no longer sharing the memory address, that of a. So we are getting the reference count of the variable a to be 1. Now before assigning a to the value none, let's assign a to a new variable a underscore id. Now let's assign the variable a none and let's pass in the address of a underscore id instead of a. I'll tell you why in just a bit. Here we are passing the reference counting of a underscore id instead of a. Now when we, let me clear the terminal, and when we run the file, we can see that the reference count of the variable a was 1 and now it became 0. That is, when we printed the reference counting of a underscore id, that is a underscore id, the a underscore id had the value of the id of the variable a, that is the memory address of the variable a. So when we printed the reference counting of a underscore id, the value, that is the reference count, became 0. Cool. You can see that the reference count of a underscore id is 0 because a underscore id had only one shared reference, and after assigning it none, it became 0. Now we know that the reference count of a is 0, and now if we pass in the address of a, we'll see a strange behavior. We have the value of none inside of the variable a. Now when we print the reference count of the id a, that is the variable a, we'll see a strange behavior. Here we get the reference count of the variable a is 2431. The reference count goes to some arbitrary number and the value stored inside of the address of the variable a changes to a different value. In the last lecture, I had told you that none takes a different place as a memory of its own inside of the memory heap, and it can be pointed to millions or thousands of objects inside of the memory address, and that memory address can have a variable which has a reference count of some arbitrary number, and in our example it's 2431. We have no clue whatsoever to which value it's being matched to. That value which has an address of a particular object might have shared references. In our case it was 2431. The variables a underscore id in our example, b and c are destroyed by the garbage collector because the reference count is 0 in those cases. I hope these practical examples are clearing up and making concepts much clearer. Thanks for watching this video. See you in the next video where we shall continue our discussion on the drawback that naive reference counting garbage collector throws at us.